In this lesson, I'm going to be talking about polar functions. About basically, this is going to be a review of what you hopefully have already learned in a previous class about polars, but it's probably been about a year because at least in Calculus AB, we don't do a whole lot with polar coordinates. So, just as a refresher, remember we have a polar grid um, where you have a point that is an r and a theta. And so you have a certain radius that you go out and a certain angle that you rotate to. So say we had the point of 4 5 pi over 3. You'd rotate to the angle of 5 pi over 3, which is this angle here, and you'd go out from the origin or the pole the amount of rings, 1, 2, 3, 4, of the radius. So it's kind of backwards of what we usually do. We graph this first, and we graph that second. So let's plot this point and name the point 3 other ways. And there's an infinite amount of ways, but I'll show you guys what I mean by naming the point a different way. So you rotate to pi over 6. I always use the same grid. So that's pi over 6, that's pi over 4, and that's pi over 3. So you go up to pi over 6 and you would go out 1, 2 rungs. So what we can do is we can name that point with a positive radius. I'm going to re-put the point on there. And a negative radius a couple different ways. So if I were to name this with a positive radius but a negative angle, I'm going to highlight this just so it's easy to see. When you're naming it with a negative angle, you're rotating from 0, rotating around negatively, and that is negative 11 pi over 6. Now with the negative radius, what that means is you go to basically the opposite line that this angle is terminal with. So like I highlight that line, and you rotate towards the angle with a negative, and with a negative radius you go away from the terminal side. So I go to this angle, which I'm going to name it as a positive angle of 7 pi over 6, and then rotating negative, we have a negative 5 pi over 6. I'm going to do another one with a negative because I know the negative always got me as a student, personally. So highlight 4 pi over 3. So 4 pi over 3. I rotate to my angle, 4 pi over 3. Which is over here. I'm going to highlight that whole angle. Yeah, that's what I want. So when I rotate to 4 pi over 3, and then I go away from that. 1, 2, 3. So that's where my point is. So now I can name that with a negative angle. I'm sorry, not a negative angle. A negative radius and a negative angle. And then a positive radius with a positive angle and a negative angle. So my negative angle would be negative 2 pi over 3. Now with a positive angle, I'm looking for this terminal side. Well, a positive angle, positive radius, that's just pi over 3. And then a negative would be a negative 5 pi over 3. Some common conversions: converting polar to rectangular, x equals r cosine theta. So let's just look at why that is. So we have our axes, and say we have out a certain radius. I have a certain theta. If you look at that like a right triangle, that's all you're really doing. I'm looking for the x, the y. The x involves cosine because it's adjacent over hypotenuse. The y is opposite over hypotenuse. So that's how we get these. And these are going to be really important to us when we start taking derivatives. Converting rectangular to polar, hopefully you recognize right away that this is a right triangle. And then the tangent is y over x. And we're going to be using, remember, inverse tangent to solve for our actual angle theta. Okay, this example. Convert that polar point to rectangular coordinates. So x equals r cosine theta. X equals -2. The cosine of a 5 pi over 6. And that gets me -1.399. And so I do the same thing. Y equals r sine theta. So y is equal to my radius times the sine of the angle, which is 5 pi over 6. So I get 1.430. I feel like one of these isn't right. Yeah, these aren't right. Where did I get these numbers from? I apologize, guys. That is not right. That should be 1.732, and this should be -1. I don't know where I got those numbers from in my notes. Holy cow. Anyway, sorry about that. Sorry there's a little bit of delay in the video. Okay, converting rectangular to polar. I think about it as we're drawing a triangle. I have -3, 1, 2, 3, 4. So I have this point right here. -3, 4. How do I get the radius? Pythagorean theorem. R squared equals the square root of 4 squared plus -3 squared. I know I flipped those. Not r squared, just regular r. And we get our radius to be 5. Now to get this, what the theta I'm looking for is rotating from 0. What I am going to find first is I'm going to find this alpha. And I know the tangent of that alpha is equal to opposite over adjacent. I take the absolute value of it. So then I get that alpha in radians to be 0.927. Now that alpha, theta, is equal to 180, not 180 because I'm in radians. I'm used to doing this in algebra 2 in degrees. Pi minus the 0.927, and I get 2.214. Okay, our next example. Using these conversions to show that the graph is a circle. So, notice how here I have 4 sine theta. So it looks like I have part of what I need for y, because y is equal to r sine theta. So if I multiply both sides by an r, we have this equation now. Now this equation is the same thing that piece is y. R squared is x squared plus y squared. If I subtract the y over, I need to show that this is a circle. So I need to complete the square, meaning I take this middle number, divide by 2 and square it, add that number to both sides. So now I get so now that's a circle with our center at 0, 2, and a radius of 2. Remember 0, 2, square root of that radius. Okay, final points of the plane that satisfy the given equation where r equals -4. Well, a lot of you are probably thinking your radius can't be negative. Well, your radius really is a circle. So I have 1, 2, 3, 4. So that's what my radius looks like. And then theta equals pi over 3. Go to your pi over 3 angle. And we highlight that whole angle. So hopefully that was a review for you of stuff you'd covered in a previous class.